7th grade J9 scale drawings word problems. Jack drew a scale drawing of a restaurant. In real life, a countertop in the restaurant is 10 feet long. It is 5 inches long in the drawing. What scale did Jack use for the drawing? Okay, so over here, they want our answer to be with a 1 inch on the left and then something feet on the right. So what I'm going to do is I'm going to draw it like this, just the way they did. 1 inch on the left, corresponding to a certain number of feet. That number is what we're going to have to figure out, okay, on the right. And the reason I'm doing it that way is because I want to make sure that I'm consistent over here. I'm going to take these numbers, 10 feet. Well, where was the feet in the way that they wanted us to write the answer? The feet was on the right side. So I'm going to make sure that I'm putting 10 feet on the right side over here. Okay, just like, so I have feet here and feet here. And then on the left side, we have 5 inches. Okay. I don't know why I wrote inch. I wrote it out over here and whatever. IN is the abbreviation for inches. Okay, so basically they're asking us, well, if 5 inches in the drawing corresponds to 10 feet in real life, then 1 inch on the drawing would correspond to how many feet in real life? I just want to make sure that I am recording here. Yeah, okay. Sometimes I get paranoid. So did we have to do that? Are we going to divide by 10 or are we going to divide by 5? Okay, that's what you have to think about. Should we be dividing by 10 here, or should we be dividing by 5? Well, I know that I want to end up with a 1 over here, and therefore I must divide this number by 5, because 5 divided by 5 is 1. But whatever I do to one side of the ratio, I'm going to have to do to the other side as well. So I'm going to have to divide this side by 5 also. So now I just figured out if 5 inches corresponds to 10 feet, then 1 inch corresponds to 2 feet. Okay? All right, and then there's my answer. Nolan measured a house and its lot and made a scale drawing. The scale he used was 1 inch corresponds to 5 feet. Okay, so here they give you what's called the unit scale. Unit because one of these numbers is 1. And we have to figure out something else. What do we have to figure out? If the actual width of the house's driveway is 15 feet, how wide is the driveway in the drawing? Okay, so, I mean, so really this is basically the same thing. We could do it like this. If 1 inch corresponds to 5 feet, then I don't know why I didn't write the abbreviation. Let me write the abbreviation for feet, which is FT. Okay, so if 1 inch corresponds to 5 feet, then how many inches would correspond to 15 feet? Well, over here, we could say 5 times 3 is 15. So then over here, we could do 1 times 3, and we would get 3. So if I already know that every 1 inch on the blueprint corresponds to, or the scale drawing, whatever you want to call it, corresponds to 5 feet in real life, then if I have something which is 15 feet in real life, that must correspond to 3 inches in the drawing. Okay? So basically what we're doing here, another way that you could have done this is to write it as a fraction. So we could say 1 inch over 5 feet equals X inches over 15 feet. And then there are a couple of different ways that we could solve for x over here. We could say, very similar to what we did over here, we could say, well, 5 times 3 is 15, and 1 times 3 is 3, and then so we would get that x is 3, which is what we found over here. Another way we could have solved that would be to say, well, 5 divided by 5 is 1, and 15 divided by 5 is 3, right? And that's another way we could have figured out that 3 is our answer. And another way that we could solve this proportion over here is to cross multiply and say 15 times 1 is 15, then put an equal sign. 5 times x is 5x, and then divide both sides by 5 to cancel this out and get the x by itself. Okay, so I drew that a little bit long. Okay, 15 divided by 5 is 3. So that's another way. So what did I just show you there? I think I showed you 4 different ways of answering this question. So I think that's plenty. So it would be 3 inches on the drawing if it's 15 feet in real life. Okay, Ava measured the middle school and made a scale drawing. The scale she used was 1 inch corresponds to 4 feet. So every 1 inch that we see in the drawing would be 4 feet in real life. If the actual width of the gym is 48 feet, how wide is the gym in the drawing? I'm just going to set this up as a proportion like I did before. As you saw from the last problem, there are different ways of answering a problem like this, different ways of setting it up. But let's just set it up as a proportion. So if I know that 1 inch corresponds to 4 feet, then how many inches would correspond to 48 feet? I know that I need to be, that's 48 feet, which is why I did not put the number 48 over here, because here I had inches. I have to do inches on the other side as well. Here I had feet. I have to do feet on the other side as well. So I have to make sure that I'm consistent on both sides. So that's how I knew that the 48 should go over here. If I had written this differently, I could have also, instead of doing 1 inch over 4 feet, I could have done 4 feet over 1 inch. And then that time, if I did it that way, then the 48 would go in the numerator, because again, I have to be consistent: feet, feet, inches, inches. So then it would look like that. So either one of these is correct for setting up the problem. Let's just do it this way. And I could cross multiply here, or I could just say to myself, well, I know that 4 times 12 is 48, and then 1 times 12, 1 times 12 is 12. Okay, so that's one way to solve it. Or you could cross multiply, or you could say 4 divided by 4 is 1, and therefore, and then divide by 4 on this side also. 48 divided by 4 is 12. That's another way we could have gotten that 12. Okay. Tanner made a scale drawing of a house and its lot. The scale of the drawing is 1 inch, corresponding to 4 feet. Okay, so 1 inch corresponds to 4 feet. 5 inches. Notice I'm consistent here. Inches, inches, and then what I'm looking for is, in real life, the actual porch would be how many feet. Okay, so I have inches, inches, feet, feet. And let's see. I could say here that having the 1 here makes it pretty easy. I know that 1 times 5 is 5. Okay, so you might be asking, how did I get that times 5? Because I'm thinking to myself, what number times 1 is equal to this 5 over here? And the answer is 5. 1 times 5 is 5. Oops, I need to plug in my computer. Got that little thing over here telling me running out of batteries. Okay, that's better. Where was I? Okay, so let's do the same thing in the denominator here. 4 times 5 is 20. Okay, so if I know that every 1 inch corresponds to 4 feet, then 5 inches must correspond to 20 feet. Okay, kind of makes sense, right? All right, let's go ahead and jump to the next level, see if we get anything significantly different over here. Here's another kind of problem we haven't done in a while. I think the first problem we did was like this, but I'll just do it again. 1 inch corresponds to how many feet? Okay, well, I know that the gym is 10 inches long in the drawing. Actual gym is 100 feet long. So I'm going to put inches over inches when I do it this way, when I'm using this strategy here. And then 100 feet over there. All right, so I'm consistent here. And then I know to get this 1 over here, I would have to divide this 10 by 10, because 10 divided by 10 is 1. If I do the same thing over here, whatever number I divide by over here, I have to divide by the same number over here. Notice I'm not dividing by 100 here. I'm dividing over here by the same number that I divided by over here. And then 100 divided by 10 is 10. So if I know that every 10 inches on the drawing corresponds to 100 feet in real life, then every 1 inch on the drawing must correspond to 10 feet in real life. Okay. All right, let's do this one. Jerry drew a scale drawing of a house. The scale he used was 7 millimeters, corresponds to 4 meters. If the dining room is 14 millimeters in the drawing, how wide is the actual dining room? Right? I know that in one of my other videos I talked about using the multiplication strategy, but I am just sticking with the proportion strategy in here. So I'm going to take this scale and just write 7 millimeters. Mm is the abbreviation for millimeters. Put that over 4 meters. M is the abbreviation for meters. And then, hang on a second. Okay, sorry about that. There was somebody at the door. Okay, and then, so if the dining room is 14 millimeters, so I had millimeters here in the numerator, I want to be consistent and put millimeters in the numerator over here as well. And we're going to be looking for how many meters that would be in real life. Okay, so we could cross multiply here. We could do 7 times x is 7x. And then 4 times 14 would be 56. And then divide both sides by 7 to cancel that out. We'd get x is equal to 8. Another way that we could have solved that is just to notice, since they gave us pretty easy numbers over here, 7 times what is equal to 14? Well, 7 times 2 is equal to 14. And then if we multiply by 14 down here as well, then we'll get 4 times 2 is 8. Same answer that we got before. All right, let's see if, I don't think this is really any different than what we had before. Let me jump a level. Okay, this is the same idea. Okay, just set up a proportion. You could do it that way. Okay, so I think I'm going to end the video there and hope that was helpful. Have a great day.